Hello and welcome to Telefunkian. Today we're taking a look at the power supply of the Roland TR-808 drum machine. The layout of the printed circuit board is shown in your screen, where you can see, indicated in various colors, the 7 capacitors that we'll be replacing in today's video. These capacitors are important parts of the filtration circuitry, filtering the positive and negative 15 volt and positive 5 volt power that is provided to the drum machine itself. And over time, these electrolytic capacitors begin to wear out, they become leaky and require replacement. Given that this machine is now about 40 years old, it's really a great idea to replace the electrolytic caps, not only in the power supply of the instrument, but throughout. In addition to replacing these, I'm also going to be upgrading them slightly. Modern day electrolytic capacitors are considerably smaller than their older counterparts, and as such, we can fit capacitors that have a higher voltage rating in place of those that were provided in the original instrument. What I've indicated on the right-hand side is the values of the original capacitors, for example, 10 microfarads at 16 volts, and listed the manufacturer's part number of the capacitors that I've used in this replacement. For example, the 10 microfarad at 16 volt capacitor has been replaced with a 10 microfarad capacitor rated at 50 volts. In addition to increasing the voltage ratings of the capacitors that I've used, I've also increased their temperature ratings, and accordingly, these capacitors should be giving this instrument many more years of uninterrupted service. A few words about the design of the power supply. The power supply is supplied by a transformer which converts the line voltage through its primary winding to 2 secondary windings, yielding 10 volts AC from one secondary, which is supplied at terminals 10 and 11 on the power supply printed circuit board, and another secondary winding with a center tap, which yields 46 volts AC split across the center tap, giving 23 volts AC between pin 12 and 13 and 14 respectively on the input to the power supply printed circuit board. This AC voltage then proceeds through either traditional fuses, glass fuses, F2, F3, and F4 in the case of the 220 volt, 240 volt version of the supply, or in North America, F2, F3, and F4 have been superseded by the use of 10 ohm, 1/4 watt fusible resistors. So if you open up your instrument and you're in North America, instead of seeing glass fuses in these positions, you should see what appear to be 10 ohm 1/4 watt resistors, which are actually taking the place of fuses. After passing through the fuses, the power proceeds through one of 2 bridge rectifiers consisting of 4 diodes in a full bridge rectifier configuration. One of these feeds the 5 volt power supply, and after proceeding through a 1000 microfarad 16 volt capacitor, it goes through a 7805 voltage regulator, which regulates the voltage, keeping it consistently at positive 5 volts, which is provided on pin 19 of the power supply and supplies the digital circuitry, which drives the timing, keeps the memory of the drum machine, and so on and so forth. The positive and negative 15 volt rails are supplied through fuses 3 and 4, power proceeding through the second bridge rectifier on the board, and then regulated by a combination of a voltage regulator chip, an obsolete Toshiba TA7179P, and 2 transistors. The 7179P is an obsolete chip which is hard to find information on, but essentially what it is doing is it is allowing the power to pass through Q1 and Q2 on the board, the 2 transistors heat sinked in the center and on the right hand side at the top of the board. So the chip itself is not taking a lot of power, but rather the power is proceeding through these transistors and then being filtered through the 2 1000 microfarad 35 volt rated capacitors shown in red. The positive and negative 15 volts are presented at pins 22 and 20 respectively on the power supply board. Of note, when the power supply is disconnected from the voice boards, it is not chassis grounded, but rather floating. It gets its ground through pin 18, which is in turn connected to the ground provided at the voice boards. In today's video, we're going to be replacing the 7 capacitors indicated in color. These are electrolytic capacitors, which over time will become leaky, meaning that they will begin to fail to act as capacitors and ultimately will begin to act as resistors. If you're having trouble with your 808, one of the first things you might want to do is check the power supply. And the best place to start actually might be at the end. And that is to verify that you're getting plus 15 volts as measured between pins 21 and 22, negative 15 volts measured between 21 and 20, and you're getting positive 5 volts measured between pins 18 and 19. Pins 15 and 16 are simply attached to the battery backup, which provides backup for the RAM chips, which keep your rhythms in memory. If you're not getting the right voltages out of your 808 power supply, it might be worth checking that you're getting the right voltages in provided by the transformer. You should be getting 10 volts AC across pins 10 and 11. You should also be getting 23 volts AC between pins 12 and 13, and 23 volts AC between pins 13 and 14. And the sum of those two voltages across pins 12 and 14. If you're getting the right voltages into the power supply, make sure that your fuses are still good, or in North America, make sure your fusible resistors haven't blown by measuring for continuity across those. Then make sure that your bridge rectifiers are still functioning and you're getting DC out of the bridge rectifiers. And then you might want to consider looking to see whether or not you've blown capacitors, the voltage regulator, or the transistors. The power supply on a Roland TR-808 is really a pretty simple device. If you've blown yours, it's really worth fixing. Hopefully, through this video, you'll learn enough about the power supply so that you'll be able to fix yours if you have any problems. So here we are. This is the power supply for the 808, and it being some 40 years old now, as you can see, it has these electrolytic capacitors filtering the power supply, and I'm going to be replacing these. The capacitors on this are Sanyos. They're probably not too terribly bad, but they are getting old. Also, I feel the need to slightly increase the voltage ratings and temperature ratings for some of these. And so I'll be upgrading some of the voltage ratings and temperature ratings. So these Nichicons are rated to 105 degrees, whereas these guys are all rated to 85 degrees. So these will last a lot longer and hopefully provide many further years of service. In addition, we have this safety capacitor here, which the modern equivalent is about this size. I'm not completely sure if I should be replacing this or not, so I'll give that a little bit of a thought, and we'll see what happens. In the meantime, I've got to release the power supply from the board so that we can get underneath it, and that screw was certainly very loose, as is this one. Gosh, these are really loose. This thing's been rattling around for a while. This one's at least slightly snug, as is this. So the power supply is held down by these 4 standoffs, and then we have quite a bit of cabling on every side of this thing. Gosh, look at this. So this here, I don't know if you can see this. This is the terminal strip, which is holding down the AC power, and this is it. I haven't loosened these at all. I don't know why this is so incredibly loose right now. It's conceivable that somebody inadvertently started messing with the screws on the other side, trying to take the actual instrument apart. But these will be snugged up, of course, because we don't want this flopping around, potentially coming loose, or for that matter, any of these screws or nuts coming loose and rattling around on the inside of the instrument and shorting something out and ruining it. So we'll see to that in a bit. So how to do this? Well, I think what I'll do is I will desolder these so that I can actually flip the board over and get underneath it. So let's see about doing that. Shouldn't really ever do what I'm doing, which is using my soldering iron tip as a chisel in order to get these wires off. But don't do as I do, do as I say. So in order to get rid of some of this excess solder, today I'm going to be using this solder wick because I happen to have a bit of it I want to get rid of. This is actually Chemtronics, which is pretty good stuff. Also got a bunch of this stuff. Solder wick brand solder wick, which is nowhere near as nice. I'll be using some of that as well because I'm running low on some of my other stuff and I wanted to get rid of those plastic rolls. I don't really care for them as much, those smaller rolls. Gosh, there's a bunch of solder on there, isn't there? Trim this off. So what am I using for a soldering iron, you may ask? Well, I'm using a Hakko FX8801 ESD safe soldering iron. Speaking of ESD, I'm not wearing a wrist strap, and there is a chip on here, so I'm actually going to slap on my wrist strap just to be sure. And under the board, I will label where these go, just so that I don't have to remember. Notwithstanding, I've got multiple channels of video recording all of this. So we'll be pulling out 1, 2, 3, 4, 5, 6, 7 capacitors, replacing them, at least 7, if not 8. Can we actually do this? Well, you know what? We might be able to facilitate this by actually removing the offending terminal strip. Put these on in the same order they came off. And to facilitate this further, I think what we're going to do is unsolder this, because we're actually going to be replacing this power cord. If you can recall, the ground pin has been torn off of it, so we'll be making some changes here. And that is old solder. The age-old trick in order to melt old solder, add new solder, and what this will do is aid with the heat transfer, we hope, and there we go. If all else fails, wait our nut. Well, if that's not coming off, it's not coming off. And away we go. This should work now. Oh, and I see we're missing a screw. That might account for some of the wobbling. Okay. Start with these little guys. Making note of their polarity because I'm not sure if the polarity is at all indicated on the board. Well, no, not really. Although I can certainly figure it out. Why leave anything to chance? Be right back. I need to get a pencil. Okay, so rather than relying on a pencil, I'll be working these on the tape, and it's minus, minus, minus. And this does seem like a little bit overkill given that I have the service manual sitting right here, and I could have just looked this up, but that's fine. Service manuals have been known to be wrong. Right? Right. Okay. Okay, there's one. This is a 10 microfarad at 16 volts. And we'll be replacing it with probably one of these guys, which will be a 10 at 50 volts. So why am I not increasing the capacitance of the power supply? Well, a number of reasons. This is not a power amplifier per se, so it's not as if having extra capacity in the power amplifier, power supply, is going to result in a better bass response or anything silly like that, but rather I'm more interested in keeping the capacitance that was designed into this power supply, respecting that, and being more gentle on the power transformer, because the capacitive load of the power transformer may, if it was increased too much, may result in a bit more stress on the power transformer, which I prefer to avoid. Okay, clean these up a little bit. I'll actually clean the back of the board with isopropanol before I resolder these. Make sure that any dirt is removed so that we get a nice, good connection. Okay. And similarly, negative, negative. Yeah, and these are all marked appropriately. Now these are single-sided boards. The traces are not as fragile as some I've seen. For example, some of the worst I've ever seen have been on Sony equipment. But nonetheless, we don't want to necessarily be too rough on these traces or on the board. We want to keep everything intact as much as possible. There's a little bit of glue underneath this capacitor, which has been used to stabilize it so that it doesn't vibrate off the board. And again, this is a 35 volt 1000 microfarad. We're going to be replacing it with a 1000 microfarad at 50 volts that's rated for 105 degrees. This is rated at 85 degrees. And of course, the ones we're using as replacements are also new, brand new. Ordered from Mauser in the beginning of May 2020, in the midst of the COVID pandemic, and they arrived the very next day. So I cannot complain about Mauser's service. They've always been very good to me, and especially given the current context, I think they're doing an amazing job. Prefer to clean as I go. I don't know why, but that's just how I roll. It's probably less efficient, but this isn't a race. use it. Hope you're enjoying watching this. This is not necessarily rocket science, but hopefully any of you who have an 808 and are interested in maintaining it, getting, again, as old as they are, almost any 808 out there would benefit from a thorough recapping, and I know this one will. So if you have a little bit of time and the requisite skills, you too can get this done yourself. And I'll remove all this sticky goo later. And I keep forgetting to put my wrist strap back on. And checking the service manual to make sure that the marking on the remaining capacitors is consistent with the actual placement of these capacitors on the board, and it is. Don't want to remove the wrong component now, do we? Wonder how many people have blown power supplies on their 808s. Probably not that many. If your power supply in your 808 blows, it's worth fixing. It's not very complicated. In fact, you could whip up one of these boards if your board had been damaged somehow. They're really pretty simple, so don't be afraid. Again, we've got a bit of glue here to deal with. On the other side, you can see it there. It's not as bad as some I've seen, and thank goodness Roland wasn't using the hot snot glue that vendors like KRK have used over the years. This stuff stands up to years of use and abuse without destroying any of the components, unlike some others. Okay. And if you notice that I've got a bit of a post-nasal drip going on, no, I don't have COVID. I've got allergies, and I'm not taking any allergy medication because of the potential immune suppressive effects associated with the allergy medication that I use. Don't ask me how I know about these things, but I do. Oh, see, that was not very good. Pulled on the capacitor when the solder was not melted, and a bad outcome. Okay, there we are, more glue on that one. And this is again another 1000 at 16 volts. It'll be replaced by a capacitor with a higher rating. Removing all that old solder. So, how's that? Look. Right. There's a bit more solder here than we need. Okay. So if I'm doing something like this, I will actually clean the board with contact cleaner or flux remover. So this is the flux remover that I tend to use. This stuff here by MG Chemicals. It's carb compliant. And I squirt a little onto not a Q-tip, but a swab, I guess. It's not a medical swab, and you can see it coming really nice and clean there. spray. I'm not shy about wiping down circuit boards, soaking them in this stuff. It doesn't really bother me. But in this case, this board is actually really pretty darn clean, although I see a bit of something there. And so it doesn't really need much attention. So I won't be soaking it. On the other hand, there are other parts on the other boards that will require a real good dousing in order to get them clean. I'm just getting old flux off of a couple of the joints on the board, but I think that's pretty good. And now I'll hit it with some isopropanol. Get rid of any residue. And this will be spotless. I'm ready for soldering. And give it a bit of a clean here and scrape off the rest of the gunk or glue. And the remainder of the glue I'll get off with this little screwdriver. I wouldn't be using this if this was a double-sided board, but given that it's not, I think we're okay. We're not going to damage anything, not anything functional. Famous last words. Just want to clear enough room so that when we use a new adhesive, that there's a clean binding surface, and it'll stick and keep the new capacitors from wobbling around and cracking the solder joints, which is what we want to avoid. So we will clean this side of the board with absolute isopropanol, meaning there's no water in that isopropanol. So all the components on this board can withstand that kind of treatment, so there's no risk to them. And again, we're doing this to ensure that when we go to adhere the capacitors to the board, that there's a good clean surface. And what I'm doing off camera is I'm just squirting a little of this isopropanol on the swab over a garbage can. The reason I'm doing that is just to use a little less isopropanol. Don't like to use any more solvents than I have to, so as not to waste them. Isopropanol is pretty abundant and can be produced in fermentation as opposed to being a petroleum product, so it's not as much of an issue as some. So that's probably clean enough for our purposes. And why don't we just put in the big capacitors first, just to be all crazy like that. So you'll notice a couple things. Maybe you won't, but I'll point them out. You'll notice that the capacitors have different length leads, and that denotes the polarity on the capacitor. You'll also notice, if you pay attention, that some of them actually have the polarity marked on them, while others don't have it marked as overtly. So on these guys, these actually these are Nippon Chemicons as opposed to the Sanyos that are on the actual audio board. These are Nippon Chemicons. They have an indication here showing you the negative side of the electrolytic capacitor, and so the other side is obviously positive. These Nichicons have the same sort of marking, but you'll also notice that the positive lead is longer than the others. So these nichicons are marked differently. They have this band here that indicates the negative lead, and of course the negative lead is also shorter. The positive lead is longer. So I think what I'll do actually is I will put in the smaller ones first, and I'll be using these guys. These are also nichicons. These are audio grade capacitors, which are not really required in this particular situation for power supply filtering, but they'll do. They're 10 microfarads, and they're rated at 50 volts as opposed to the ones that they're replacing, which were 10 microfarads rated at 16 volts. So they should do just fine. And as you can see, the polarity markings are still visible on my tape and consistent with the service manual. Out you come. We'll save you for something that matters. Aha! Here's some 10 at 50s, and these are Rubicon YXFs, and they should be just fine for this application. Right. If anybody wants to disagree with me, please let me know in the comments. Just clip these leads off rather than playing tug-of-war. So these were from my local electronics supply, Lee's Electronics. So now you know where I live. So I'm just bending the leads over on the other side. I apologize, you can't really see that. And now I will solder these puppies in. Start with one lead on each side, on each capacitor rather. And then straighten them out a bit as best as I can. Okay, it looks good. They're all nice and cool. Trying to get rid of the stray leads off the board so that we don't end up with lead clippings floating around on the inside of the instrument later. Of course, when we do the audio board, we won't be doing it over the chassis like this, but still. Okay, to inspect our work. I think that's okay. Yep. Okay, next. This is our 470 microfarad at 25 volts, and it's replacing this guy, which was 470 at 16 volts. In keeping with our theme of taking advantage of the fact that modern capacitors are actually, they tend to be smaller for a given capacitance and voltage rating, and so we're going with these higher voltage rating capacitors, which are the same size as the old ones, and also upgrading to 125 degree capacitors. So if I can remove all my chemicals and my capacitors from the service manual, I'll just confirm the polarity on this fella, and indeed Yep. He goes here, and with the negative with the negative lead towards these two large caps. So I'll be bending these, but also trying to hold this guy in place. So he's quite happy there. So I'll just solder it. Trying to make sure I'm applying my solder to the pad, not to the tip of the soldering iron. Again, make sure that is okay, and of course it is. Applying leads. Okay, that's nice and flat, and so I'll take the adhesive that we'll be using later. Our next capacitor, our next victim, is this guy. He's a 1000 microfarad at 25 volts and is replacing this 1000 at 16 volts. This is an 85 degree capacitor, and this again is a 105 degree capacitor. It should last forever. And again, confirming the polarity, it goes in like so. Make sure it's flat. So I don't pretend to be an expert on electrolytic capacitors, but what I have done is I've selected some audio grade Nichicons for the audio board, regardless of whether or not they're actually in the audio path or are being used as bypass filter capacitors. Just trying to keep things simple. But here in the power supply, I'm using capacitors that are really better suited to this application. And with these longer leads, we can hold on to them as we clip them so we don't lose them. There we go. And two more. So one of the things that one might imagine doing when refurbishing a board like this is taking these heat sinks off and refreshing the heatsink paste. And I've contemplated doing that, but I've looked at it and it's actually quite pliable. It's not dried out. There's plenty of it there. So I'm actually going to leave these alone rather than disturb these devices. We've got a voltage regulator and then two transistors here. I don't want to be doing anything to compromise those, so I'll leave them alone. And these last capacitors go in such that the negative supply, the short lead, is facing away from the these devices attached to the heat sinks. So that's one. You can see it fits in perfectly, and that's one thing you do want to look into when you're ordering capacitors for a rebuild like this, is you want to make sure that the footprint of the capacitor that you're replacing or replacing an older capacitor with is matching that of the device. And so that means that the lead spacing is consistent and the device is going to fit. You also want to make sure that the height of the device is similar to the previous one. This is going to be going, this board mounts underneath the audio board and has a heat sink above it, which is mounted to the audio board. So there is not an infinite amount of room for these capacitors. So we want to be mindful of that. This is pretty thin solder. It's because it's solder that I use typically to be soldering surface mount devices, not big massive capacitors. Another inspection. Sure, I think all that's good. Now the thing about replacing this safety capacitor that makes me a little nervous is the fact that the footprint is very different. You can see that the leads for the one that I'd be replacing are much further apart. And as such, what I would have to do is I'd have to drill a new hole and then insert the lead in through the hole and then bend it. You can't see that, I apologize. So these are the lead for the safety capacitor, which is mounted on the other side. So I'd have to drill a hole here and push the lead through and bend it over and then solder it to this pad here. And I'm not really sure I want to do that. These safety capacitors are designed to fail open, and if it were to fail open, it's no big deal. It's just not providing the filtering that was designed into the device. So maybe I'll just leave that there. And what I need to do before I am able to mount this board is get an M3 screw to mount this standoff. So I'll locate that and be right back. Okay, so what I've determined here is that we had one standoff that was free. It didn't have anything holding it to the board. 3 that were actually mounted. 2 with the correct screws, these black M3 Phillips head screws, and then 1 with this, which is sort of a flatter screw, which, although it looks just fine, it's not correct. I don't have an abundance of the correct screws. What I have are these, which are M3 8mm. So I'll be using these temporarily until I can resupply myself with some of these. I think these are M3 6mm screws. So I'll have to be sourcing a bunch of those shortly. So I'll screw in the standoffs from the other side. I will not be using Loctite at this point, which I normally would do if I were securing standoffs. And you can see that previously there was green Loctite or some other compound used to secure the screws in these standoffs. You can see the residue there. So it wouldn't be completely inappropriate of me to reapply fresh Loctite, but I won't be doing that right now because I'll wait until I have the correct screws to take care of that. Come on. So tomorrow's Mother's Day. Don't forget, any of you who are watching this after Mother's Day, those of you who are watching this after Mother's Day and did forget about Mother's Day, well, woe be to you. Because if I forget about Mother's Day, my wife will not be happy. Happy wife, happy life. Come on, where are you? I'd rather not scratch up the bottom of the 808. Use my pliers to secure that. Okay. Now, is there enough room for these screws with my 8mm screws on the other side? That's something I should have measured, isn't it? What is the answer? The answer is no. Another good reason to replace those screws on the other side, but they'll stay there for the moment. because I can replace them after the fact. Then I'll be tightening these up. Okay, so what next? Well, as you can see, we've disconnected the power, the terminal block, and why they use a terminal block, I do not know. It's conceivable, frankly, that this was screwed in rather than soldered, and maybe these broke over time. I'm not sure. Perhaps the previous owner took off. It's really difficult to say. Yeah, so I am debating whether or not to actually put to solder this on, or to use lugs and screw it on. But I think what I'll do is I'll solder it on. But in the meantime, I'm going to be replacing this cord because it lacks a ground plug, and it's also been damaged. You can see right there the insulation is off of it. So I think what I'm going to do is take care of that right now, and that will involve undoing this cord clamp, or at least releasing the tension on it. I'll leave it in place, in situ as it were, and damn you. Oh, you're even smaller, aren't you? When all else fails, use a wrench. See, this guy's got a lug, soldered onto a lug, and so we will put a lug on our new ground plug as well. Okay, I'll measure this and see if I have a cable that is long enough. So I have a cord that we can use. It's only 6 feet long rather than 8 feet long, but 6 feet long should be fine. Why do we care how long it is? Well, we want the cord to be long enough so that if the 808 is on the top row of an instrument rack, the cable is going to go all the way down to the ground and be able to plug into a power bar on the ground. If it was plugging directly into an outlet, that adds another 18 inches of length. So this should be fine. Now, things to think about when we're looking at replacing a cord. This is likely a 16 gauge wire here, and it is carrying a certain amount of power. How much power is it carrying? It's carrying, well, it's rated for quite a bit of power, but the fuse in this instrument is a 0.5 amp fuse, so it shouldn't be really carrying that much power. Nonetheless, we want to make sure that this cord has a certain amount of capacity, and so we're going to check out the gauge of the wire on this. So we're looking at about a comparable wire gauge, so that's good news. Bad news is I didn't trim off quite as much wire, but I think we should be fine. That's about the same. It'll be fine, won't it? Won't it, folks? So I don't believe I have the exact type of lug that I want there, so I will reuse the one that has come off the instrument. Of course, I can't see what I'm doing because the other wires are in the way. There we are, I think. Great. Aha. Unbeknownst to me, there's a hole in this, which is fine. I'll just clip that, and that will help us remove the wire. There we go. Into the bin. One of my favorite memes of 2020 was the meme referring to the parties they used to throw at the Packard plant in Detroit, where people were saying that if they could survive the parties at the Packard plant, there was no way that COVID-19 was going to get them. I wouldn't be so sure, but nonetheless, I like that one. Oh, amazing. Where's my vise when I need it? Ow! It really doesn't matter if this is on straight or not, but if I was really anal, I'd be putting a piece of shrink wrap on it and all that jazz. In fact, maybe I should. Okay, plenty of room, plenty of room. We can screw that in. Gosh. So this is filthy. And so I'm going to clean it because it needs to make good contact. We can't afford it not to. This is again deoxit. We'll soak these in deoxit. Put a little deoxit there. Hopefully not destroying the little earth label. That's how you can tell this machine was made on Earth. That's what that means. Richie Houghton had an 808 that was gifted to him by an alien race, as did, of course, Richard James, Aphex Twin. But most other 808s are made right here on Earth. Yeah, that's kind of dirty. I'll come back and clean this again later, but in the meantime, when I'm putting this together, I just want it to be clean enough so that it works properly. Isopropanol, rinse. Good thing about all this organic stuff is it doesn't really destroy that paper. Enough of the swabs. I use a Q-tip, which is, of course, a swab by another name. Okay. This is blue Loctite, medium strength, and it will keep these, keep this together. Just help keep it together. And I'm just screwing this screw in, which doesn't match the one next to it, kind of strangely. Seems like we have a little theme here in that regard. Okay, I'm going to mount the terminal block and then desolder it before I resolder these. Okay. So, flat washer, lock washer, nut. And again, these seem to have fallen victim to some overeager disassembler of the instrument who started unscrewing all of the screws on the bottom and loosened everything, which makes me think I should be examining the transformer mounting as well, which I will do. Okay, so I was a little quick on the draw putting this away. I forgot to shake it up last time, but now it's a little bit more viscous, which is what you want. And hold the nuts and screw it all together. Probably off camera, I apologize. Oh, more evidence this was made on Earth. It says made in Japan right on it. There we are. Okay, making progress. Let's see what's under all this gunk. Some more wire. Oh, there's actually a hole in there. Okay. To the garbage with that. Much preferable when all these come out at once, but alas, I ran out of talent. Okay. It's far too much deoxit to be spilling on the board, on the instrument, so I'm going to clean this up. Sorry folks, that was a mistake. Deoxit is wonderful stuff, but it does contain lubricant, and that's essentially an oil. It will eventually probably attract some dirt, which we don't want. Okay. By the time we get all this done, the board will be well and truly dusted. So good mechanical connection. And a good electrical connection coming right up. Does that mean? Okay, and these guys go here. So what are we doing? Probably can't see, so I'll move this over. We are soldering the backup battery connections. Okay, so this is our rebuilt power supply, and we're going to go through it and make sure it's getting all the correct voltages. Starting off here at the input, where we should be seeing 120 volts AC, and that's indeed what we see. We've got 120.9 volts on the line coming into the instrument. The line voltage then bridges over to the PCB here, goes out to the switch, and comes and returns from the switch here and here. That's right. And then goes to the primary on the transformer here. So the primary is seeing 120.7 volts AC. So then we have our first secondary coming back. That should be 10 volts. These two yellow wires here. And it's 10.6 volts. 10.7-ish. That's fine. Then we have our secondary winding, and across this winding we should see about 46 volts. 43.6. 43.6. And then we should see half of that in between the center tap, which is this black wire, and we see 21.7 and 21.8, and that's fine. So the AC portion of the power supply seems to be working just fine. If we go over to the 5-volt rail, it's the negative is this terminal here. Then we should see 5 volts DC right here. And we see 5.1 volts DC. This is the backup power for the memory, and we're seeing essentially 5 volts there as well. And if we had batteries connected, we'd see about 4.5 at the batteries here. This is our positive and negative 15-volt rails, and this is the 0 volt for that split power supply. So this is the negative 15.1 volts that we're seeing here in between the black and the blue wires, and then we're seeing 15.1 volts positive in between the black and the red wires. And so everything appears to be working properly. If, for example, it was not, we might expect that these fuses here, these are fusible resistors, they might be blown. Of course, the fuse itself, the glass fuse, could be blown. We could have problems with our bridge rectifiers here, the 5-volt regulator, the transistors, or the TA7179, which is the regulator for the 15-volt portion of the supply. But everything in this power supply seems to be working just fine. So, congratulations, we did it.